Hey you guys, sorry I had to miss class today because I was sick. I hope you all are doing well. Today I'm going to do a few word problems from your homework. I'm going to attach a document as well that has all of them on there in the order that we're going in, just because I have a really small whiteboard as you can see. So it's kind of hard to write the whole problem on there. So I'll read it. I think I'll also try to put it inside the video, but we'll see how that works with iVideo or iMovie or whatever it's called on Macs. So yeah, with that being said, for sure you'll get a document attached to your to the email that I send this in that will say, hey, here's the questions. So our first question is, it says compute the table for a savings account subject to continuous compounding. And so that means that we're using the PERT formula, A equals P times E to the RT. And we're told that P is 5,500. The interest rate, R, is going to be 0.13. It's 13%. And we're told that A is going to equal 11,000. So if we look at this, we're actually computing the double life because we're starting out with half as much as we want to end up with. So we're finding the amount of time it takes to double our funds. It won't say double life anywhere like on your test or anything. Later on we're going to talk about half life. So that's why I said double life. That's up to you. So anyways, so we start out by writing our formula. We have 11,000 equals 5,500 times e to the 0.13t. So we're looking for something that's in our power. So first things first, we need to divide both sides by 5,500. When we do, we get 2 equals e to the 0.13t. So then from there, we need to rewrite this because right now we're looking, our t is in the power, and the only way we can solve for the power is using a logarithmic function. So that means we're going to have 0.13t equals the ln of 2 and divide both sides by 0.3 or 0.13. So we get t equals the ln of 2 divided by 0.13, and you can use your calculator to figure that out. So that's our answer for the first one. Alright? Alright, so now we're going to continue on to the next question. It says we have an exponential model. A equals 23.6 e to the 0.031 t. Describes the population of a country in millions and t years after 2003. What year will so this one actually has two parts. The previous part was in the previous question, so it's not on this. The first part asks what's the population in 2003. And for that one, all you do is plug in 0 to t because 2003 is 0 years after 2003. So that's not that bad. So for this one, though, we're asked to find when the population will be 44 million. So that means our A is going to be 44 million. So we have 44 equals 23.6 e to the 0.031 t. So we divide both sides by 23.6. And I don't have a calculator with me. Of course I don't. So we get 44 over 23.6 equals e to the 0.031 t. And then we have to rewrite it. So we get 0.031 t equals the ln of 44 over 23.6. And then we just divide both sides by 0.031. So t equals the ln of 44 over 23.6 divided by 0.31. So whenever you put this in your calculator, do the ln first and then divide that answer by 0.031. So number 3 says an artifact originally has 16 grams of carbon-14 present. The decay model is A. Oh no, my marker's dying. Hold on. A equals 16e to the negative 0.000121 T. And that describes the amount of carbon-14 present after T years. Use this model to determine how many grams will be present in 5,555 years. So this one is actually more of an exponential. All we're doing is plugging in. So we have A, equals 16e to the negative 0.000121 times 55, or 5,555. That's all you have to do, because T is years, so you just plug it in, plug and chug, and go. It's not that hard. So then you can plug it in your calculator and figure it out from there. And then we have one more, and this one's going to take a little bit. It's a two-step problem, so I'll come back on one side. So it says the half-life of a certain substance is 29 years. How long will it take for the substance to decay from 73 to 73% of its original amount? It says use the exponential decay model. A equals A naught times E to the KT. So first things first, we need to figure out at what rate this substance is decreasing. So we're going to start with the fact that we know the half-life is 29 years. So we don't have to be given any other information than this to find out the rate. So we can find out the rate by saying, okay, well, if my original amount was 1, then the final amount needs to be a half. So I have 1/2 of the principal equals the principal times E to the K times 29, right? Because 29 was the number of years. And I can divide both sides by P, and I get 0.05, or 1/2, equals E to the 29K. And then I rewrite it in my logarithmic form. So that's the ln of 0.5 equals 29K, and then we divide both sides by 29. So we get K equals the ln of 0.5 divided by 29, which when I plug this in a calculator like I am about to do on the computer, so you guys gotta watch me type it in. Oh no, this isn't an advanced one, never mind. Time out. We're gonna see. There we go. I have the ln, 0.5, we're going to take the ln of it, we're going to divide that by 29, and we get that K equals approximately a negative 0.02391. I'm going to take it out to 6 places just because even though we're going to round to 1 decimal place at the end, we might need that, rounded out more just because our powers end up making big differences in logs. So it helps not to round until the very end as much as possible. So I'm going to use this information. So now we know that K equals a negative 0.023901. And so now we're going to talk about the second part of the question, which says that we have 0.73p as our final. So we're changing A from being 1/2 because we found the half-life and that helped us find the rate, to now we're actually using our real A, which is 0.73p. That's 73% of the original amount. So we have 0.73p equals p times e to the negative 0.023901 t. Because we're looking for the time it takes to get to 73% of the original amount. So we get 0.73 equals e to the negative 0.023901 t. We rewrite it as the ln of 0.73 equals a negative 0.023901 t, and then we divide both sides by that amount. And we get, as I use my calculator again, the ln of 0.73 divided by a negative 0.023901, and that gives me approximately, so t, if I can get this marker right, is approximately 13.2 years. And that's my answer. So hopefully this helps you guys with your homework. And I will see you guys tomorrow as we start a new topic. So make sure you're in class because it's your next project too. So there's a lot going on. So we'll talk more about it tomorrow. Anyways, see you guys.